Welcome to the DIHICLE project, part of the FLUIDOS First Open Call, where we explore dynamic workload migration based on network range. In this demonstration, we show how FLUIDOS enables smart and efficient workload migration between several edge servers in order to support a moving ARM64 device moving among them. Let's dive in and see it in action. Our scenario involves a drone performing powerline inspections for the energy grid, helping facilitate predictive maintenance. These grid assets are distributed across a large area, requiring the drone to connect with different base stations as it moves. Edge servers positioned near these base stations provide the computing resources needed for the drone's operations. The inspection process is powered by 3 microservices: the camera app, which captures the video feed from the drone, the detection app, which analyzes the video using AI or ML algorithms to identify potential faults in the power lines, and the decision app, which determines if maintenance crews need to be notified, sending the GPS location and relevant video frame if necessary. The camera app and decision app run directly on the ARM64 powered device mounted on the drone. However, since this device is resource-constrained, the resource-intensive detection app is offloaded to an edge server. This is where the FLUIDOS project steps in to provide dynamic resource provisioning. In this demo, we simulate a drone flying through the range of 2 base stations, each with its own edge server. As the drone moves, it automatically discovers new edge servers and exploits their resources if the connection to the previous server is lost. The detection app is seamlessly migrated to minimize downtime. In FLUIDOS terminology, the drone acts as the consumer, while the edge servers act as the providers. The DIHICLE stack, running on the consumer, includes 2 key daemons: cluster discovery, which binds new resources, and cluster failure, which triggers migrations on failures. Let's see this process in action. On the upper part of the screen, you'll see the 2 edge server providers and their software stacks, including FLUIDOS Node, LICO, and Multis, running on K3s clusters. The lower part of the screen displays the consumer setup with a similar software stack. When the consumer enters the provider's range, it automatically registers it as a resource. The cluster discovery daemon then launches a solver to check if the required resources are available and binds them. Once verified, a namespace is created and offloaded, and the application is deployed with the camera app and decision app on the consumer and the detection app on the provider. This selection is performed by specifying the offloaded namespace in the application's YAML file. When a new provider is discovered, as already mentioned, its resources are auto-bound in case of a disconnection from the current provider. The apps keep running without interruption. In the migration phase, when the first provider goes out of range, the cluster failure daemon detects the issue. It then automatically redeploys the detection app to the new provider, maintaining seamless operation despite the connection loss. And that concludes our demonstration. We hope this demo highlighted how FLUIDOS and DIHICLE enable robust and dynamic workload migration for edge computing scenarios. Thank you for watching. If you have any questions, please don't hesitate to reach out to our team.